The lesson outcome for this video is I can use power rules. In this video, we're going to talk about the fourth and fifth power rule. We've already discussed the first three. The first thing I'm going to do in this video is actually just run through those three rules just to make sure they're still, you still remember how they work. So, first of all, the product of powers. Well, the product of powers rule says that if we have a product of two powers, I'm going to try and make that a dot there. Product means multiplication. If I have, let's say, a to the m power, and we have another base of a, and it's raised to the n power, what that means is that we can keep the base of a and add the exponents, m plus n. Okay, sorry for my slow moving there, but I was trying to remember what this third column is for right now, and I just remember what I'm going to use that for. Just a really quick example. So if I have x to the third power times x to the fourth power, that will be keep my base of x and add my exponents. So 3 plus 4 is 7. All right, now the power of a power rule, power of a power. So that means we've got a power situation, we've got a base of a raised to an exponent m, and that power is raised to a power, let's say n. Well, the rule there, remember, is that we leave that base of a and we multiply the powers. So we take m and multiply it by n. So an example of this, if I have x to the third and then raised to the fourth, I'm going to use the same numbers to show you the difference here. This will be x to the 12th. Okay? And then our third one is a power of a product rule. And a power of a product means that we've got a product in our parentheses, so let's say a times b, and it's raised to a power. Well, remember that the rule is that we can take both a and b and raise it to the m power. So a to the m times b to the m. And an example of that might be x times y in parentheses raised to the third power. And what that will be is we can raise x to the third, and we can also raise y to the third. Okay, so the fourth rule is the quotient of powers rule. All right. Now the quotient of powers rule, we're going to again explore in our first example. So x to the 8th over x to the 3rd. Now if you think about what this means, okay, x to the 8th means x multiplied by itself 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. And then x to the 3rd power means x times x times x. Now, if you think about how with a fraction you can always cancel out, or what's called make a 1, a factor in the numerator, the top, with a factor in the denominator, the bottom, we can cancel out or make a 1 3 different times, meaning x divided by x is 1, x divided by x is 1, and x divided by x is 1. So we've canceled those 3 x's out. And what we have left here is we just have x to the 1, 2, 3, 4, 5. So our answer here is x to the 5th power, and we don't need our denominator. We could write over 1, but we don't need a denominator anymore because all of these are gone. So our answer is x to the 5th. So the rule, if you can notice here, we have an 8 right here and a 3 right here. If we take 8 and subtract 3, we get 5. And that's what we've done. We've taken away those 3, and we have 5 left. So the rule up here is that if we have a base of a raised to the m power, over a base of a raised to the n power, we can leave our base of a and we can subtract the m, the numerator exponent, minus the n. Now I'm going to talk through this next example a little bit differently because although I'm always going to be using the quotient of powers rule that I talked about up here, that we're subtracting the exponent m minus n, there's a different way I like to talk about the quotient of powers rule while I'm doing further future more complex examples. And that is, I like to say if you have a base on the top, let's say w, and the same base on the bottom, w, what I like to ask to simplify this is, where do we have more w's? Okay, because if we wrote this out, it would be 5 w's multiplied together, and if we wrote this out, it'd be 4 w's multiplied together. So where do we have more? Well, we have more on the top. And how many more do we have on the top than we have on the bottom? Well, 5 is 1 more than 4. So what I like to end up doing here is saying, all right, since I have more w's in the top, in the numerator, I'm going to put a w in the numerator. And I'm going to say, well, I know there's only 1 more in the top than in the bottom, so we know it's going to be w to the first. And then we ask the same question with our y's. Where do I have more y's if I expanded these? Well, I'd have 4 y's being multiplied together, and here I'd have 2 y's being multiplied together, which means I have more w's in the numerator. So I'm sorry, y's. So there's my y in the numerator. And how many more do I have here than here? And that would be 2. So our final answer, if we want to rewrite this a little bit, w to the first just means w, and y to the second power, y squared, goes here. And then again, there's not a 0 in the denominator, just so you know, this is not a 0 right here. We always know that there's a coefficient of 1 in front of all variables, so this would just be a 1, which means we don't have to write that in our final answer over here. Now I'm going to show just one more example here using that same process. So let's say I have a to the 8th power times b to the 3rd power times c over a to the 5th power b to the 6th power c to the 3rd power. Okay? So using the process I just talked about, let's just start with our factors that have a base of a. So we have a base of a here and a base of a here. If I expanded this, I'd multiply 8 of those together. If I expanded this, I'd multiply 5 of those together. So where do I have more a's? I have more a's in the numerator. How many more a's in the numerator than in the denominator? Well, 3, because 8 is 3 more than 5. And then where do I have more b's? Okay, oops, sorry, I'm missing some stuff here. I just deleted something. A to the 3rd, sorry about that. All right, so where do I have more b's? Well, I'd have b times itself 3 times and b times itself 6 times. So I've got more b's in the denominator this time, so I'm going to leave my base of b in the denominator. And how many more b's do I have down there than in the top? Well, 3. Okay, again, I'm going to just show this quick. If I expanded b to the 3rd, I'd have b times b times b. And on the bottom, I'd have b times b times b times b times b times b. If I canceled some of those out, this b divided by b is 1, b divided by b is 1, b divided by b is 1. I've got 3 b's being multiplied together in the denominator, in the bottom portion of the fraction. So that's why I have b to the 3rd in the denominator. Now we could do the same thing with the c's. So I've got a c here, and I've got c to the 3rd down here, so c times c times c. And if I wanted to cancel that c out with one of these, c divided by c is 1, we're left with 2 c's in the denominator, which means we've got c squared left down there. And then this would be our final answer for that. And our 5th rule is the power of a quotient rule. The power of a quotient. I didn't mention this on the previous page, but remember, quotient means the answer to a division problem. So we're talking about division here, and same as on the previous screen. So the power of a quotient. All right, let's go ahead and look at this first example down here again. X over y raised to the third power. Now what does x over y to the third power mean? It means multiply x over y times itself 3 times. And then if we multiply fractions, we multiply straight across. So what we're doing here is we're multiplying x times x times x and y times y times y. Well, x times x times x is x to the 1, 2, 3, x to the third. And y times y times y is y to the first times y to the first times y to the first, which is a base of y, and we add 1 plus 1 plus 1, and we get 3. So our answer is x to the third over y to the third, which tells us that all we need to really do is make sure that both or everything in the parentheses that's raised to the third power gets raised to the third power. So x to the third, y to the third. That's our rule up here. A over b raised to the m power is a to the m over b to the m. So let's just try one last example. If you look at x times y over z, all raised to the fourth power. Pay attention to where your parentheses are and what's being raised to the fourth. It's the whole thing. So we just need to go ahead and raise everything, every factor in the numerator and every factor in the denominator to the fourth power. So x to the fourth, y to the fourth over z to the fourth. And now nothing else can be done because each and every base, x, y, and z, each base is different, and that's as far as we can take that problem.